Okay, guys, so our 4 review problems for today from quiz 1, again. This was an error analysis. In which line was the first mistake made? What was the mistake? And what should the correct answer be? So this would be one of the ones where you would be multiplying either a box method or FOIL, whichever works for you better. 5z minus 9 times 6z plus 3. And for those of you who've reached out about error analysis problems, for me, it's easier to take the problem, which is your first line, this right here, and then just take it to my own paper and work it and then compare. Because sometimes you convince yourself someone else's work is right. So 6 times 5 is going to be 30. And then we have z squared, because there's a z and a z. Negative 9 times 6 is going to be a negative 54z. 5z times 3 is 15z. And negative 9 times 3 is going to be a negative 27. So in this case, I have my 30z squared here. I have my 15z here. And then that 54. So this would be the error. So the first, what line was it? Would be in line 1. And the error was that 54z went in as a positive instead of the negative 9 times the 6z. So that negative here is the actual problem, that this was positive. And then what should the correct answer be? Now, answer is when you're finished. So 30z plus 15z, sorry, my z's look like 2's, minus 54z minus 27 is not the answer to the problem. Because remember, we're in high school math, we always condense, combine like terms, and simplify. Especially when you get to your next math class, leaving things expanded is a thing of the past. We're always going for the most simplified answer. So the correct answer, even though they did this 54 wrong, this is still your correct answer. Somehow they magically did the math right. So the error again was in line 1. It should be a negative 54z, and the correct answer is that 30z minus 39z minus 27. So they just needed to combine these. All right, so that's problem number 1. Number 2, so this is factor by grouping. So factor by grouping, because there's 4 terms. You can maybe even pull out a GCF if you wanted across the whole thing, but I would just stick with factor by grouping because there are 4 terms. So as soon as you see 4 terms, then you can think about a GCF if you want, but I would just go straight into grouping to make it work. So since there's 4 terms in grouping, number 1, we're going to group the first 2 and group the last 2. So looking at x to the 4th and 5x to the 3rd, we know they have x's in common. And as I said in the beginning, take the lowest exponent, and that's how many you know you can pull out of that first one. So that means I'm going to be left with an x, and I'm going to be left with a 5, because there's 3 x's on the outside. This has 4, so 1's left. You can put a 1 in front of it if you want. Then looking at the second one, I have 3 and 15, so 3 is definitely a GCF, and there's an x in both, so I can pull out an x. And now, ideally, if you were factor by grouping correctly and you pulled out the correct GCF, this parentheses should be this. So I'm just going to pretend like I know that, and I'm going to cheat. So 3x times x is 3x squared, so that's good. And 3x times 5 is 15x, so that's good. So since these 2 match, we know we did it right. Our first factor set is going to be our 2 numbers in the front. They're going to come together. And you're going to have x cubed plus 3x. And then the matching pair is your other factor. So it's factor and factor. So we didn't solve it. All we've done is factor it by grouping. So this is factor by grouping. There was a couple call outs on needing some help on that. If you'll send me specific questions, I'll address them in future videos. All right. So then is it possible to factor this expression? So this is factor by grouping, like line 2. So like we are looking at that one right here is all they've shown. So after they've pulled out the GCF. So our 6x to the 3rd power plus 7 would have to be our first factor if we could factor it. But these have to match. This is a plus and this is a minus. So they don't match. So that means it can't be factored this way. That means it's not the same thing, because otherwise we can't just pick one. They have to match, because then we would have one more factor in this case. So y and 2. But since it's plus and minus, this does not work. So you cannot factor this one. So this is just your basic trinomial factoring with a equal to 1. So this would be just your basic x, probably for most of you when you learned it in Math 1 or 8th grade. And then you can still use that big star like I've talked about if that one's making sense to you. And that's where a times c goes on the top, b goes on the bottom, a times x goes in the corners. And then we're going to treat these not fractions. We're going to pretend like they are. So remember, this is ax squared plus bx plus c. So our value of a is 1, our b is -1, and our c is -42. So a times c is going to be that -42. So that's going to go on the top. And then our b value is a -1. A times x would be 1 times x, 1 times x. And then ACB chart, so the factors of -42, that will add or subtract to give you 1. So we have 1 and 42. 2 times 21. 3 times 14. And 5, 6 times 7. And then the next number will be 7, which is already here. If I add 1 and 42, I get 43. If I subtract them, I would get 41. If I add, I get 23. If I subtract them, I get 19. If I add 14 and 3, I get 17 or 11 if I subtract. Add 6 and 7, I'm going to get 13. If I subtract, I'm going to get 1. Now, that 1 is what we were looking for. So we know that this is going to be our factors that we're going to use. So 7 and 6. B is negative, so the largest of the two factors is the one you want to make negative. We're going to look at this not fraction, see if we can reduce it. It's a 1, so we know we can't. So the number on the top goes in the front, and then the number on the bottom goes in the back of our first factor. Look at our not fraction again. 1's on the top, so it's not going to be reducible. So x plus 6. So this would be if it factored completely. Now, you can always check this, especially if it's a multiple choice question. You can check this by foiling it or by a box method and coming out and seeing if it's where you started. Combine your like terms. And that is where we started, except there wasn't a 1 in our first one. Your other option to check this, because you have access to Desmos, if you type this equation in your first line and then this equation just as is in your second line on Desmos, the two graphs should overlap. If they don't overlap, there's a mistake. Either you didn't put it into Desmos correctly or you made a mistake in your factoring. So you do want to check and make sure you didn't accidentally put a plus where there should be a minus, or accidentally leave out an X or anything like that, because human errors happen. But if you can accurately put this in line 1 and your answer in line 2, if it is correct, your graphs should overlap. All right, guys, that's your 4 problems for the day. Have a great weekend.